Welcome to Week 1, Introduction to the course, and an overview of data sources. This week, we'll be introducing what data science is, taking a look at data sources, and writing our very first lines of Python code. This course is designed for learners who've never ever written code before. We're assuming no prior experience here. If you have prior experience, that's a bonus. It's not required. By the end of this course, you will know how to identify different data file types, for example, the difference between CSV and Excel files. You'll be able to write code to read data files into Python. You'll then be able to use Python to clean, explore, and analyze those files. Build ordinary least squares or OLS regression models using Python and the libraries associated with it. And finally, we'll create some basic visualizations like graphs using data we read into Python. Let's talk about the motivations of this course. What is data science? Well, the answer you receive to this question depends on which consultant you're asking. Berkeley defines data scientists as professionals who are skilled in organizing and analyzing massive amounts of data. Now, what does massive amounts of data mean? Well, it could mean more data than you can fit in your head. Organizations are dealing with larger and larger data sets, and unfortunately, we're having trouble extracting the value from that data. This is where the computer tools can come in and help us extract value. Another major vendor, Oracle, defines data science as an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract value from data. So why does data science matter? And why should we become good data scientists? Well, we're up against a challenge. According to a survey that was commissioned by the Business Application Research Center, 58% of executives said that they've based their regular business decisions on gut feel or experience. That same study found that only 22% used mostly information, i.e. data science, for their decision making. The two biggest barriers to those data-driven decisions: it's deferring to gut instinct over data for decision making, and feeling overwhelmed when working with data. If we feel overwhelmed, our brain has a tendency to flush out anything that's too complicated for us to understand. This is an opportunity. Because becoming a data scientist is more than just running some code and providing an answer to stakeholders. It's about gleaning the story from insights that are revealed by the data. Remember, computers are a tool in our data science toolbox. Computers are great at running repetitive calculations. You, as a human being, are good at telling a story. So our opportunity here is to use data, to parse that data, and give it a voice so that we can use data to help make better public policy decisions. You bring your knowledge, your experience, and your intuition to every problem that you tackle in your field. And you can use that intuition to help guide conclusions brought about by analyzing data. Before learning to code, if you wanted to run a regression analysis or clean data for graphing, you would need to do that manually. This is time-consuming. It's prone to error. And it takes time away from what you're best at, which is interpreting and communicating the results. Our goal for you in this course is to reduce the time that you have to spend on these manual tasks and shift them to the computer. You're good at the storytelling. The computer's good at the calculation. With less time spent on the tedious tasks, you'll have more time to spend on interpreting and presenting the data's story. Always remember that computers are great at running repetitive tasks like calculations. We can use code to quickly explore complex regression models and figure out relationships between variables. One word of caution, though. When you're writing code, your computer will give you output as a result. In this course, we will be talking about results and output, not answers. Why not answers? Well, answers imply a level of correctness. Results are the products of the inputs given to an algorithm. The primary reason we talk about results is because it leaves the responsibility of the meaning of those results up to you, the data scientist. As part of our approach to data science, you need to learn to think like a scientist, which means you can ask questions that can be falsified. For example, you could postulate, I believe that the sky is red, and you can subject that to a test, an empirical test, by going outside and looking at the sky. And when you see that the sky is blue, you've falsified your hypothesis. In another example, you're trying to determine if there's a relationship between smoking rates and lung cancer incidence. And in order to prove this true, you hypothesize that there is no link between these variables. You create a regression model that produces a result that the probability of no link between smoking and lung cancer is less than 5%. That tells you that there is enough evidence to reject your hypothesis that there is no link between smoking and lung cancer and accept the alternative hypothesis that there must be a link between smoking and lung cancer. In order to produce some of your best work, you're going to have to try to remove your emotion from the situation whenever possible. As part of the data science process, you may receive results that run counter to your intuition. You may receive results that run counter to your values. You must always be willing to ask yourself, what does this result mean? Go beyond the result that the computer gives you. If you receive a result that surprises you, challenges your worldview, dig in. Find out why you got that conclusion. Always think beyond the first-order consequences. Keep asking yourself the question, and then what? So smoking causes lung cancer. And then what? What do we do with that information? What is the impact of any policy that, say, would target reducing smoking rates? What would the impact of that policy be on society? Ready for some good news? You are already a programmer, and you might not even realize it yet. If you've ever given step-by-step instructions about how to complete any sort of task, microwaving popcorn, how to get to work, guess what? You're a programmer. All programming is writing instructions that a computer can run in a language that a computer can understand. The difference between humans and computers, however, is that humans can fill in the blanks if we miss a word or get the syntax of a language slightly wrong. Computers cannot infer. It's all or nothing. Either the code runs or it doesn't. For example, if I said to you, microwave a glass of water for 2 minutes, then take it out of the microwave, you probably inferred some of the steps involved in microwaving a glass of water. For example, getting the glass of water and filling it up, putting the glass in the microwave, closing the door, pressing 200, start, waiting 2 minutes, waiting for the beep. After the beep goes off, pressing the microwave door and fetching the microwaved glass of water. Computers are unable to fill in those blanks. So we will need to be careful how we talk to our computers. But know that if you've ever given anyone step-by-step instructions, congratulations, you're a programmer. Let's talk about the 5 steps of data science. Berkeley defines 5 major steps of data science: capture, maintain, process, analyze, and communicate. Capturing is when we enter data into a system. Maintaining is when we clean and prepare that data for processing. You may work for organizations that have dedicated departments that handle these steps. Perhaps you have a department that has an extract, transform, and load, or ETL process. Once the data has been captured and maintained, we can now process it, where after it's been cleaned, we can ingest our data into a model of some sort. This is where we will spend the majority of our time in this course. We'll be running regressions and finding correlations. We can also lump the data cleaning that we will conduct into this step. Finally, after we process the data, we need to interpret the results given to you by the programs we write, and we need to communicate our findings to decision makers and key stakeholders. Arguably, the real work begins here. We will spend the majority of our time in the process and analyze phases. And our data cleaning will slot into the process side of data science, but we're also going to talk a bit about communication in week 7.